So we'll come back to addition in a moment, but I want to jump into subtraction right now. So just like with addition, we need to know two things to be able to subtract fractions. One, we need to know what is a fraction. And we kind of got that down now. And standard thing is equal parts of a whole. And the whole could be anything we want it to be. We could use a hexagon, we could use a square, we could use a colored strip. And two, in this case, what does subtraction mean? And we have a bunch of options for subtraction. The one I'm going to go with right now is subtraction is a comparison. And the comparison asks how much more is one number than another. Sorry, my Zoom screen is in my way. Go. And another. And other options for subtraction are, we could say subtraction means take away, or we could say subtraction means what do I add? Was another way we did with it, or we could play around on a number line. But I'm going to go with the comparison interpretation of subtraction. So let's try to do 1/2 take away 1/3 and see what we get. And again, for the comparison, you have to show both fractions. So I'm just going to draw a half. That's a very good one. Marginally better. And going with the theme and the addition, I cut one in one direction and the other in the other direction. So I shade in, okay, here's my half here. And maybe this one's going to be my third right there. And I can see a half is bigger, but like how much bigger? Well, it's a little bigger, but that's not a good enough answer. We want a numerical answer, not just it's a little bit bigger. And the problem is related to this equal parts of a whole, these aren't equal parts. And the easiest solution to the equal parts is to cut each like the other. And so the half gets cut in thirds, and the thirds get cut in half. Now they're cut the same way, and we can look at it a little different. So now instead of calling this a half, we're going to say, okay, that's 3/6 of a whole, and this one is 2/6 of a whole. And we can see that the 1/2 has one more piece than the third, and that piece would be called a 1/6. So the result here is 1/6, since 1/2 is 1/6 larger or bigger than 1/3. Okay, so with the comparison, we see them both. I'm not taking away. We could do the takeaway, but the picture looks slightly different. So like addition, we have to deal with this equal parts of a whole thing. And the comparison is a lot like the combine and count. We can only compare if the pieces are the same size. So I'm going to look at a bit more complicated problem next. Let's switch cameras. Okay, so hopefully you see, isn't it showing me? Come on. Something's wrong. There we go. So here is my image here. So I have two fractions going on here. The top one up there is, I'm going to use two hexagons as a whole. So this is 1, 2, 3, and a 4th. And then I want to compare that to 1, 1/3. Okay. Now, as far as the comparison goes, we're trying to match stuff up. So this hole could match up with that hole right there. Okay. So maybe I'm going to take those away for a minute because they matched up. The problem is this matching is a problem. There's not enough here to compare with what's down here, right? 1/3 is bigger than 1/4. So what do? How do I deal with that? Somehow these other two have to come into play. Okay, so I guess I could trade one of these holes in. So I'm going to trade one hole for 6/6 or 3/3, depending on how you look at it. And now I can match some stuff up. So let's see. Let's pull that out. These guys can be paired up and pulled out. So now I'm kind of combining the takeaway. And this is my answer. This is the difference right there. So I was trying to answer the question, 3/4 is how much bigger than 1/3, and it's this much bigger. What is that much? 1 and this stuff here, almost 2. The difference is almost 2. What am I going to do next? I don't have a clear answer. Any suggestions?
Switch those in for green triangles?
Yeah, I don't have a common denominator. I gotta find a common denominator. It turns out in this case, the green triangle is the common denominator. So I'm gonna trade those for some green. I gotta trade this for some green. And then the blue one, I gotta trade for some green. Oh, get back here. Okay. Oh, all right. So that's a little more clear. It looks like the difference is 1 and 6, 7, 8, 9, 10, 11 twelfths. Okay. So the common denominator still matters whether I look at subtraction or addition, whether I look at subtraction as takeaway or comparison. That was a tough problem. And like with kids, I would have done a ton of little problems before I did that big one. But I wanted to jump to a bigger issue with this on top of finding a common denominator. So let's do that. So I just attempted to illustrate with the pattern blocks 3 and 1/4, take away 1 and 1/3. And it quickly got messy. And a lot of times when we write problems like this, it comes stacked, or we're told to rewrite it like this, 3 and 1/4 minus 1 and 1/3. All right, so let's see. So what I tried to do next was I tried to do a subtraction. Like I said, 3 minus 1 was 2. So I'm just going to do that. 3 minus 1 is 2. But then this was a mess, and I had to do some trading. And then from this 2 right there, I traded one of those in, and I ended up trading it in for 6/6, which is a whole. And all of a sudden it's like, ooh, this is like totally messy there. So we realized later, oh no, we need a common denominator. So let's try this again. 3 and 1/4 minus 1 and 1/3. And now you guys have a lot of experience. What would you suggest the common denominator is here?
12.
12. Okay, so we go for 12. So we're going to rewrite that 1/4 there as a number of 12s. To do that, I'm going to multiply top and bottom by 3. So I have 3/12 there. And here I want 12s. So we're going to have to remodel that one, multiply top and bottom by 4. So that's 4/12. And I'm trying to do a subtraction here, but I can't take 4 from 3. So, uh-oh, I have to borrow. Okay, so let's see, I borrow from the 3. What am I borrowing from the 3 here?
12 twelfths.
I'm borrowing 12 twelfths, right? So I'm saying 3 is 2 and 12 twelfths. Combine that with my 3 twelfths here gives me what, 15 twelfths? 15 minus 4 is 11 twelfths. 2 minus 1 is 1. That was interesting. This was complicated and messy, no matter how I did it. Can I get around that messiness? I'm going to try, and the way I'm going to try it is I'm going to rethink the 3 1/4 as an improper fraction. So let's see, 3 times 4 is 12. 12 plus 1 is 13 fourths. 1 times 3 is 3, plus 1 is 4 thirds. And then I need a common denominator. We decided on twelfths. So multiplying top and bottom by 3, multiply top and bottom by 4. 13 times 3 is what? 39 twelfths. Minus 16 twelfths, which doesn't seem too bad. That gives me 23 twelfths. All right, it's about the same amount of work, but this whole borrowing here is tough because the kids are so used to borrowing a 10, right, and making that a 13. So this right up here is going to be a common place for kids to make a big error. It's hard enough to find that common denominator, but then realize that when you borrow a whole number into a fraction, you're borrowing based on the denominator. So that is a really difficult problem in this direction for kids. This tends to be easier down here, less likely for errors. So what are some things about subtraction I'd like to point out? Subtraction, like addition, whether I view it as takeaway or comparison, requires a common denominator. And if we're playing around with mixed numbers, I believe that for most problems, improper fractions are easier to calculate with. And the next thing I want to look at is beyond these models, because I don't want to have to draw pictures or use the pattern blocks every time I want to add or subtract fractions. I want to be able to do it without. Like here, we did it without. So one thing we've come to realize from using the toys over and over again is whether we're using addition or subtraction, we have to have a common denominator. So the next question is, how do we find a common denominator?